So today we're talking about parallel. First thing we're going to do is see what they look like. So series, I got my battery, 1 resistor, 2 resistor, 3 resistor. They look like that. It is in one box. Everything's nice and neat in one box. Parallel, you have your battery. Okay, besides the fact that my resistors aren't greatly drawn, you can see how there are multiple boxes here. And all the resistors are in conveniently enough parallel lines. You can draw like that. Or like that. Okay, well, hopefully they will make a nice straight line there, but you get the point there. Either way, that's a parallel. It's multiple boxes. Does everyone see that? We good? Yeah. Listen, guys, if y'all have to look at mine to draw your, I expect better than mine. Please. Not those, though. I appreciate that, and this is not one, though. All right, so when we think about holiday lights, we often think about series and parallel. If one bulb goes out on your Christmas tree, does the whole string go out? No, not usually, right? But a part of it will. Like, you'll have a whole chunk of your tree that stops being lit. The reason is holiday lights are usually used with both parallel and series. They used to be like completely parallel, but like the cost of wiring now, no bueno. So what they did is each section is in series, and then all of them are connected in parallel. So if one section goes out, the rest of the lights still work. All right. So in the past, we've said series has an I in it, so I is the same. The reason we say that is because parallel has two L's next to each other, which basically can be made into a V. Resistors and parallel have the same voltage drop. So series I is identical, parallel V is identical. Any questions so far? Okay. We have a 9-volt battery, a 7 ohm, 5 ohm, 4 ohm, 2 ohm connected in a parallel. So I filled it out. We're going to put my 9-volt battery right here. And because parallel has two L's, which basically make a V, that 9 goes all the way up.
So if it's a parallel, the V is constant?
Mm-hmm. And if it's series, the I is constant.
Will the R ever be constant?
No.
Okay.
That's it. These are the only two types where we don't combine them in on level, which is nice.
So would we do 9 divided by 8 too?
So hold on. You're getting there ahead of me. All right. For this particular exercise, we need our handy dandy calculators. If you do not have this because your girlfriend, boyfriend, mother, dog, best friend's car keeps it, you're going to have to do this the long way. You're going to have to do this the way the video just showed you. So no calculator. To find my R total, you would have to go 1 over 7 plus 1 over 5 plus 1 over 4 plus 1 over 2. And then you'd have to equal it and then flip it. And that's gross. With our calculator, it's so much easier. All right, you ready? Y'all ready? My first one is a 7. So I'm going to write 7 right there. I'm going to turn on my calculator. All right, there's a little right here. I'm going to go 7. You ready for the magic? That button. Wow. Underneath the math, it's x to negative 1. And just look at this right here. X to negative 1 is 0.1428, blah, blah. 1 over 7 is equal to the same thing. That button puts it on the bottom of a fraction for me. So I have to do it. So to solve this, I go 7 to the negative 1 plus 5 to negative 1. All right. And look how all my steps right here are written. Plus 4 to the negative 1 plus 2, plus 2 to the negative 1. Like that. Okay, I'm going to hit enter. Gives me 1.092 blah, blah, blah. Okay, now my formula up here says 1 over R total equals 1 over R1 plus 1 over R2 plus 1 over R3, blah, 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 blah. This means that is 1 over R total. That is not my total. That is 1 over it. I don't want that number. I got to flip it again. So I'm going to hit that X to negative 1. See how it says answer to the negative 1? It's going to take my answer. It's going to flip it. I'm going to hit enter. My total resistance is 0.92. With some rounding. Did everyone get that on their calculators? Yes? No? Okay. It's gross. It's not a nice pretty one. It is what it is. Okay. Now we're going to use totals to find my current. Voltage divided by resistance. So 9 divided by 0.92. 8. Okay? Then I got to do that for each row. 9 divided by 7. 1.3. 9 divided by 5. 1.8. 9 divided by 4. 2.3. 9 divided by 2. 4.5. Okay, then my check it. 1.3 plus 1.8 plus 2.3 plus 4.5 plus 0 because I just hit plus too many times. 9.9. 9.9 and 9.8. I got some wiggle room. That's because I've been rounding this whole time. So I am correct. These all equal about the same because of rounding. Gross, right? It's not as easy as series, but it's not horrible.